What if the next computing revolution wasn't about shrinking transistors, but rewriting how intelligence itself scales? Meet Jenson's Law, the new playbook for AI's explosive future, quietly reshaping industries and nations alike. For decades, Moore's Law spawned bigger, faster chips through relentless transistor shrinkage. But Jenson's Law, emerging but not yet codified, shifts focus to intelligence expansion. Named after NVIDIA CEO Jensen Huang, it signals a paradigm shift from silicon scaling to cognitive architecture. The numbers reveal what traditional metrics miss. NVIDIA's AI inference performance has surged 1,000x over the past decade, not just from better chips, but by overhauling the entire tech stack. Think of it as upgrading from a standard bicycle to a self-driving motorcycle fleet. Redesigned chassis, new fuel systems, advanced navigation software, and real-time coordination mechanisms. This stat transformation isn't controversial, it's disruptive. Why this matters? Current CPUs can't handle tomorrow's AI demands. Training massive models today requires baskets loaded with GPU firepower, consuming energy equivalent to small towns, and stressing cloud systems designed for simpler tasks. But here's where it gets controversial. Some argue we're rushing into specialized AI chips, ASICs, without solving their real-world limitations. How many companies can afford custom silicon development? And should nations prioritize chip sovereignty through fabrication when talent shortages already stifle progress? Jenson's Law demands 3 uncomfortable truths. 1. Passive innovation won't suffice. Every tech level, hardware, software, global policy, must actively evolve to support AI. 2. Coordination becomes science. Think of silicon as musicians, software as conductors, society as composers. 3. Intelligence isn't a tool. It's infrastructure requiring the same strategic planning as power grids or transportation networks. The stakes aren't just performance metrics. Consider India's bold move beyond coding to controlling chip-making and talent pipelines, a nod to NVIDIA's stack monopoly. Cloud providers embracing ASICs face a catch-22. Scrap reinventing the wheel or risk losing edge. Chip companies now sell not just faster processors, but articulated roadmaps for AI's next decade, a subtle but seismic shift in tech business models. Moore's Law promised predictability. Jenson's Law demands adaptability. The real debate isn't about which vendors dominate, but can our systems keep sanity while AI runs faster than society's institutions can regulate it? Consider self-evolving supply chains making decisions daily that we previously handled quarterly, or real-time medical diagnostics rewriting healthcare workflows overnight. We're building flying cars without traffic laws. Here's what most discussions miss. Jenson's Law isn't a physics law. It's a systems pressure mechanic. Exponential graphs in KPMG's semiconductor outlook, 86% expecting growth, 70% boosting RD. Talent drought still #1 issue. Suggest a meme, but paint a civilization-scale transition. Compute is no longer just data processing. It's becoming cognition infrastructure. A new generation of platform architects is quietly addressing this. They're not just bolting AI layers onto old systems, but crafting coordination substrates, like smart fabrics organizing neural networks, reasoning engines that self-optimize for energy, and sovereign infrastructure that keeps AI's scaling safe and controlled. Think of them as unrecognized architects in a new computational civilization. The next decade won't be about transistor counts. It's about who masters the art of system intelligence. For the first time in computing history, collaboration between silicon, software, and social systems emerges not as an option, but as critical infrastructure. We'd love to hear your take. Should nations prioritize chip sovereignty, like India, or focus on global collaboration to avoid fragmented AI ecosystems? Drop your thoughts below, and let's debate.